When I say prompt engineering, what comes to your mind? ChatGPT, LLM, and AI chatbots, right? That's totally cool. But I would like to talk about the principles behind prompt engineering, which are very critical for us, especially when we are knee deep in the world of Hadoop, Spark, and big data. In this data driven world, we build robust data pipelines, ensure data quality, optimize storage, and make sure our processing frameworks are working efficiently. Also, we are not just moving data, we are manipulating that data too. This is where prompt engineering enters the picture. What is prompt engineering really? At its core, prompt engineering is the art and science of crafting effective inputs to get desired outputs from an AI model. It's about being incredibly precise, clear, and structured in how you ask a model to do something. It's about understanding the model's capabilities and limitations, and then strategically designing your questions or instructions to elicit the most accurate, relevant, and useful response. Think of it like this. You wouldn't just throw a bucket of raw materials into a complex manufacturing plant and expect a perfect product. You need a detailed blueprint, precise instruction for each machine, and a clear sequence of operations. Similarly, with AI models, especially LLMs, you can't just throw raw data or vague questions at them and expect gold. You need to provide a specific workflow for their thinking process. Why is this important for the data engineers? Here is why it's becoming absolutely crucial for us, especially in the big data ecosystem. Data context and quality for AI. Garbage in, garbage out. Reimagined. We have lived by garbage in and garbage out for years in data warehousing. Now it's not just about data cleaning, but about contextually rich data. A prompt is the ultimate form of context. If the data we are feeding into an AI model lacks the necessary context for effective prompting, the model will struggle. The ground truth for generative AI: when an LLM generates text or insights based on your data, it's hallucinating if it's not anchored to facts. Our job is to ensure the data used for grounding is accurate, timely, and accessible. Prompt engineering relies heavily on this grounding data. If your retrieval augmented generation RAG system pulls irrelevant data because of poor indexing or pipeline issues, no prompt can fix it. Building effective data-driven AI applications. Vector databases and semantic search. Many data engineers are now building and maintaining vector databases. These databases store numerical representations of text, images, or other data, enabling semantic search. Optimizing data flow for LLMs. Think about a scenario where a data scientist wants an LLM to summarize daily sales report stored in HDFS. Without prompt engineering mindset, we might just dump raw text. With prompt engineering mindset, we would consider how can I pre-process this data to make it most prompt friendly. Should I extract key entities, summarize sections beforehand, Structure it as JSON within the prompt. How large is the context window of the target LLM? Can I chunk the data intelligently? This is all part of a data engineer's domain. Efficiency and cost optimization in big data ML workflows. Reducing AI rethink cycles. Poor prompts lead to irrelevant or inaccurate AI outputs. This means more iterations for data scientists, more reruns of models, and more processing power consumed on our big data clusters. Data minimization for prompts. Large prompts cost more money because of the more token usage and hit context window limits. As data engineers, we can help processes and filter data so that only essential information is included in the prompt, reducing costs and improving efficiency of LLM calls, especially when dealing with massive datasets. Automated prompt generation. Imagine automatically generating prompts for an LLM based on data patterns identified in your Spark jobs. This requires a deep understanding of both the data and the prompt structure. The future is hybrid, data plus AI expertise. Bridging the gap, data engineer sits between the raw data and the end user applications. When those applications are AI driven, understanding prompt engineering helps us bridge the gap between what data do we have and how can AI effectively use it. Troubleshooting AI issues. If an AI model is giving bad answers, it might not be model's fault. It could be bad data, bad prompt, bad retrieval. Data governance for AI, ensuring data privacy, security, and ethical use in prompts. What sensitive data are we allowing into the context window of an LLM? This is a huge data governance challenge that we, as data engineers, are uniquely positioned to address. Practical examples in a big data context. Scenario 1. Customer support chatbot powered by Data Lake. Our role. You have built pipelines ingesting customer queries, product manuals, and frequently asked questions into your Hadoop data lake. You are building a RAG system, prompt engineering for data engineers. How do you chunk the product manuals so the relevant sections can be retrieved for a prompt? Example, small, semantically meaningful chunks versus huge pages. How do you ensure the metadata attached to each document, for example, product version, date, allows for precise retrieval to prevent hallucinations about outdated information? When the user asks, how do I fix error XYZ? How do we ensure the retrieved context from HDFS is especially about fixing the error, not just mentioning it? This influences your vector embedding strategy. Scenario 2. Anomaly detection in IoT sensor data, Spark or Kafka. Our role, you're streaming IoT sensor data into Kafka, processing it with Spark, and storing aggregates in Parquet file format on HDFS. Now, a data scientist wants to use an LLM to explain why an anomaly occurred based on the aggregated data and system logs. Prompt engineering for DEs. How do you structure the anomaly data and relevant log snippets into a coherent, prompt-friendly format like JSON or clear key value pairs so the LLM can easily parse into interpret it? How do you select the most relevant logs for a specific time window around the anomaly, preventing prompt overload? This requires precise filtering and section selection within your Spark jobs. Can you pre-process and categorize log messages to make them more digestible for an LLM when included in a prompt? In conclusion, Prompt engineering isn't just a buzzword, it's a rapidly evolving skill that's blurring the lines between data engineering, machine learning, and even UX. For us, it's about extending our expertise from managing data to optimizing data for intelligent consumption. By understanding the principles of prompt engineering, we can build more effective and efficient data pipelines for AI, ensure the quality and context of data used by LLMs, contribute directly to the success of AI applications by optimizing the data's presentation, future proof of our career in a world increasingly powered by AI. So, next time you're optimizing a Spark job or designing a new data schema in Hadoop, ask yourself, how will this data be prompted? Am I making it easy for an AI to understand and use the information effectively? That shift in mindset is your new superpower in the age of AI.